Hi, my name is Milan, and today we're gonna solve the antiderivative of the following problem. First, what we're gonna do, we're gonna use the distributive property of the power of 2 that it's affecting the parentheses. So, 3 to a power of 2, it will be 9, and it's x to a power of 2, it will be 4, minus 3 times square root of x, that the square root of x will be resolved to x to a power of 1/2. So in the end it will be 6x 5 over 2 plus x alone, the square root to a power of 2, it will just leave as an x. So now we're going to multiply what's on the outside for what's on the inside. To make it easier, the x, we're going to turn it out to 1 over 2, x to a power of 1 over 2. So 6 times 9, it will be 64, 54, x 4 divided by x to a power of 1/4 minus 36x 5 over 2 divided by x 1 to the power of 2 plus 6x divided by x to the power of 1 2. Now we're gonna simplify by taking all the x's out. So in the first it will be x to a power of 7 over 2. In the second it will be x to squared plus the third is just gonna be x to a power of 1/2. Now we're going to antiderivate, which consists of adding one whole number to a power and then dividing it by that number, as you can see. And in the second it will be 36x over 3 to a power of 3 over 3 plus 6x to a power of 3 over 2 over 3 over 2. So now we're going to simplify or use the tortillazo method. So 2 times 54 will be 108 x 9 over 2 over 9. Then that the second will stay the same, and the last one, it will be 2 over 2 times 6, it will be 12 x 3 over 2 over 3. And at the end we're just gonna simplify it. So what was on the top will be divided what's left on the bottom, as you can see, and that will be our final answer.
This problem says the cylinder increases its radius and its size with it. It asks us what will be the change of cost of painting it on the outside when the radius is 2 and when the radius is 2.4. To do question A about the real additional cost, we need to get the surface area formula for a cylinder and plug in the value of the first radius, then multiply it by $13.5, and now that will be the cost. And we repeat the same process for the second radius and compare answers. This is how the faces of a cylinder looks like. And then we have the formula of its surface area. For our problem, the height of the cylinder stays at 6 meters, and the radius is the one changing. So we use a formula, we're gonna replace h by 6. So we use the formula of the surface area and we plug in the radius of 2. Then we solve, and that will be our surface area for radius number 1. And then we multiply it by $13.5, so we know the price of painting it. Then we're going to do the exact same procedure, but instead of putting radius as 2, we're going to replace it for 2.4. And then as we solve it, we also multiply it by $13.5, and that will give us our final cost of the cylinder number 2. Okay, so we're gonna subtract the price of the second cylinder with the first, so we get the real change of the cost. That will equal to $352.8. This is the real change of the painting. To get the percentage, you need to divide our result by the original price of the cylinder number 1 and then multiply it by 100. And the answer will give you 25.99%. To estimate, we're going to use the formula that we used before, but we're going to derivate it and then multiply it by the differential of the radius. When we do the formula, we're going to plug in the radius, the original radius that we know. And instead of dr, we're going to plug in the difference, which is 0.4. Then the answer that it gives us, we need to multiply it by 13.5, which is a cost, and that will be our final answer, which is $339.
Okay, so letter D asks us, is the estimate bigger or smaller than the real one? The estimate will always be smaller because in the formula we have a square. This means, like in a graph, that formula will be like a parabola, and the estimate is the tangent line. So if you're getting this point and this point, there's a difference. There's a small difference, and that's the estimate. That's why the estimate is smaller.